Hey, how's it going? It's been a long day. I know for me, I get to that point where I'm like, wow, so many new and interesting things. How can I handle one more? Well, there isn't too much more. There's me, and then Chris is coming up after me, who's also got some really interesting stuff. So let me just kind of familiarize myself. How many people here are working with retrieval augmented generation? Anyone? Anyone? Yes. How's it going? Not so good? Good. All right. Awesome. Anybody working with graphs or have worked with graphs before? And all right, I love seeing the same arms coming up. Awesome. So GraphRAG is not new to you, which is exciting. So for those of you who are not familiar, we're definitely going to cover some of those pieces. And just know at the end, I will talk about Microsoft GraphRAG and Neo4j and how all that fits together. Because I know, is that why people were curious about Microsoft GraphRAG? Anyone? Oh, then don't worry about it. Easy enough. All right, so obviously, we were talking about retrieval augmented generation. We recognize that generally, your LLM is going to give you a direct response. The user asks a question, you get an answer, right? But when we're doing RAG, which is retrieval augmented generation, we're trying to bring facts into it because we know LLMs are creative, which is their job, but there are certain facts we do not want them to be creative about. We want it to be grounded in our data at the enterprise level or whatever your project is that you're working on. So we're looking for these complete and curated responses. So what happens, as we can see in the diagram, is the user asks a prompt. The GenAI application takes that in, creates the vectors, and then says, okay, let me go into this data source and get some actual facts and bring those back. So bring the facts of your database with the creation of the language around it, rather than creating the facts themselves. So then the question becomes, what do we use for this external data? And we can see across the bottom what a lot of folks so far are using is their unstructured data. The way a lot of this comes up is in, chatbots. Anybody working on chatbots? Yes. Anybody working on GenAI talking to structured data? A little bit, okay, yep, we're working on that. So you've got your vector databases, you've got your unstructured data, you've got your structured data, and then maybe you've got some document stores or some semi-structured data. And the question is, we have all these different types of stores in our architecture. How can we actually bring them all together and answer these kinds of questions? Say if we're in a chatbot or some other type of GenAI application, how do we leverage all these different pieces together? And one of the ways that you can do that is by adding a superset data structure on top, which is the knowledge graph, which you can then use for RAG. So we're going to talk about that a little bit today, and I'm going to show you some fast ways to get started with that. So for those who are not familiar with Graph, I'm just going to give a very brief introduction to what is Graph. In Graph, we have nodes which represent entities. In our case, we're looking at two people in a car. These entities have relationships. These people may know each other. They may live together. One may own the car. One may drive the car. And so when we're looking at it in a traditional, let's say if we had a tabular database, we would have a table of people. We would have a table of cars. The car's primary key would be the foreign key to whatever the car was that the person owned, et cetera, et cetera. But in the case of a graph database, all of that information is already connected, and it's connected through these relationships. Now, you may say to me, Alison, that's all well and good, but I know in my tabular data, there's a lot more facts. So we also have properties in your graph. So you have properties on the entities, like we're seeing here, maybe the person's name, their birth date, their Twitter handle. We have properties on the car, right? And we also see maybe in this particular one, we've got the description embedding down underneath in the car. So you can actually, maybe we have a full text description of this particular Volvo V70, and we also have the embedding of that description, right? So like we were talking about before, you don't necessarily need to have a separate vector database. You can also have the vectors here. But what's interesting too is that the relationships themselves also have properties. So let's see, Andre is driving said Volvo V70, but he's been driving it since a particular date. So just recognize if you're newer to Graph that they are very robust. And you want to make sure that you have the right database and the right tool at the right time. No one's going to advocate for you throwing out all of your tabular databases. But there are certain instances where having these types of relationships and these types of data structures can be very helpful. And one of the ways that this comes up is when you're using graph in your retrieval augmented generation. So one of the things that happens, we enhance the relevance with more domain context. And what do I mean by that? We know that when we run a vector search, we hit a particular vector based on cosine similarity. It's maybe a particular piece of a chunk, but maybe we're missing some context. Or maybe there's a structured piece that we want to connect to. So if we even go back to here, if we're looking at the description of the car, maybe I want to know about, maybe there's a review, right? And I want to, maybe I would say, oh, tell me about reviews of this V70, right? Maybe it's not just the car, there's another node that's a review. And it takes you to that chunk, and that text chunk is related to a review. But that review was written by a person, and maybe that person, has a number of friends or works for a particular company. So sometimes the answer that you're looking for, while you go to the data through the vector, there's actually something structured that's really, really important that you want to get to. And so what using GraphRAG allows us to do is it allows us to explore that relevance and understand where in the data that's coming from. Can give you that context. Obviously, improve explainability, human readable relationships. Like everybody loves a vector store. I feel like, where you're in the matrix, right? It's just like all the numbers and you're like, okay, arrays are great, but what does it say? It reminds me of just now when she was showing the IDs and the talk, like what does it actually mean? We need to be able to justify what's coming out of our LLM prompts. And so in this case, if we have a chunk and it's connected to this particular person or this particular entity or this, piece of structured data, it allows us to bring explainability to the table as well. And then the other thing too is there's a lot of tooling around graph that's really helpful. Like Llama Index has a ton of things that they've built. Neo4j is always building things. There's lots of different folks out in, both open source and otherwise that are providing these tools to let you leverage GraphRAG. So it's going to get you moving pretty quickly. So just so that we know how you actually go ahead and build this, obviously we've got these various data sources. We've got our various types of data. You can choose which embedding models you want, and then we have the knowledge graph as well. And you're like, okay, Alison, this is all well and good, but okay, let's just say I have everything in a graph. How am I even going to get it? This particular slide here is the one where I would say if you leave here and you start doing something on your own, think about these things as you move forward. Because what we talk about when we talk about GraphRAG patterns is it's not as simple as basic RAG, where you say, I'm just going to do my vector search and I'm going to bring it back and I'm going to have this thing. You have to start to think about what are the other pieces of information that are going to be helpful. Am I looking for, say, text to cipher? Cipher is the sequel of graphs, right? And don't worry, you don't have to learn a whole new language. We have text to cipher. It's pretty okay. So, maybe there's something just structured in the graph itself that you're trying to retrieve. Maybe you actually want the vector search plus the graph context, which is what I was talking about before. Takes you to this chunk, but you want something that's related to that chunk that's coming back. You can filter that graph. So like we have in lots of different scenarios, you may need a pre-filter or a post-filter on that vector search. Obviously, it's the year of the agents, as we all know, so you likely have some multi-step process. So when you're thinking about expanding your RAG application and you're looking to leverage graph, what you want to start thinking about is you want to start thinking about what is the relationship between the structured, this unstructured, or the semi-structured that might be helpful to me, because that's going to drive how you build the application. Okay. All this well and good, but Alison, I've never even built a graph before, and I've got all this unstructured data. What am I going to do? So the first thing I'm going to tell you is what I want you to do specifically as a follow-up to what I said on graph patterns is to think about the data that you have, right? Do you have structured? Is it unstructured? Do you know what it should look like? The first tip is start small. Do not try and put your entire enterprise unstructured data into a GraphRAG application tomorrow. Your bosses will never forgive me, and you won't forgive me either because you'll be super frustrated. So start small. Find a small use case. Maybe there's some place where you already have a RAG implementation and you want to add in some kind of context in this manner. Then you want to evaluate your data. What do you have? Structured, unstructured? Is it a combination thereof? And the reason you want to think about this is going back to the graph patterns. You want to understand, how am I going to leverage those connections to get better answers? And then once you do this, I'm going to encourage you to draw your data. And what do I actually mean by that? We have something called Arrows. It's just an open source tool, and it's a way of actually drawing out your data. The reason that we want you to consider this is to recognize that if you're going to be traversing a network, you need to know what's in the network, right? This particular one that I'm going to show you today is actually my husband's research. He does policy research on special education in Vermont. And what he had started out with, he's an academic, so his data looked like this. So he had all these organizations and sub-organizations and links to PDFs and all these things. And what he was trying to do is he was trying to understand, policy development over time. And, I have a soft spot for him and a Google Sheet. So I was like, okay, let me help you a little bit. So what we did is we took the basics of his data and we set it out like this. So as we can see here, it's pretty straightforward. Within special education, you've got a person, right? Somebody works for the Department of Education. They are part of a particular organization. That organization has a document, and that document covers a particular concept. The other thing you see a self-reference there where one document might reference another document. Most of his work ended up being in that because he wanted to see lineage of participation and lineage of reference and different things like that. Not so relevant to the overall process, but the reason I bring this up is, what are the kinds of questions that you're answering in your RAG application right now? What additional pieces of information would you love to be able to answer if you could? He wanted to answer, well, how does this document relate to the past one? Or who were the people that were involved? So now when he runs his application, he'll get the question and he can say something like, who are all the people involved in writing documents about X, right? Act 173. It'll go into the vector and then it'll go through the graph and find those. So just to understand, so Arrows is a really easy way to just sketch out and draw your data. And most likely, like most people, they say things like, Alison, well, that's all well and good, but I don't even know what's in this data. It's like enterprise-wide. Like, I don't know what kinds of questions they're answering. What am I supposed to do now? If you don't know, we have additional options. And not just setting up a graph database. We went to the wrong one. So many tabs to show you. We have something called the LLM Graph Builder. So what Neo4j did is we said, listen, we know that people want to use GraphRAG, but they don't actually know what's in their data. So what you want to be able to do is, in this scenario, in this particular piece, by the way, anything I show you today is either open source or has a free piece available. So it is not a sales pitch, FYI, everything's open source. So in this particular case, this is an interface that you can connect to your database, and you can do a number of things. You can upload PDFs, you can drop in a web link, you can drop in Wikipedia pages. If you've got an S3 bucket or a GCP store, what it will do is it takes that data in and it will actually build the graph for you. Now, admittedly, the way that it works is it goes through and it does entity recognition on those documents. Then after it recognizes the entities, it says, okay, what relationships do we have between these entities? And so it may not come out looking exactly like you may want it, but that's the whole point. The point is to understand, I don't know what's in it. Can somebody give me sort of a guide? So the guide will be through the graph builder. So I'm actually going to do this for you live. And if you were here for the last talk, they said there is no demo gods, just one demo god, which is rehearsal. So I've rehearsed this a couple of times, so hopefully everything will go well. So as I said, my husband's working on Vermont special education. This is just the home page. It's got a couple of things, but what it does list out is it lists out everyone who are the people that work for the Vermont State Department of Education. So I am going to copy this. I will tell you my computer was being really weird this morning, so hopefully everything goes okay. So I'm going to go in here, and then I'm going to go into web sources. And then you have two choices, either a Wikipedia link or a general web source. So I'm going to go to the website link, and I'm going to paste that in, and I'm going to submit it. Submit, there we go. So now it actually created the source node. So the first thing it does goes through and creates the node. Then it's going to end up processing that. So right now, I'm going to show you the IDE we have, which is Workspace. So I had a completely empty database, but now we should have one node, which is the document. And so as soon as I drop that link in, that node is created. So this node here is the document, and these are all the different properties that we have. When was it created? What's the file name, file source, things like that. So my database was empty, now we have this. So now what I can do is I can now click on this, and let's say, let's generate a graph. So now when it's generating this graph, it's going to go through that processing of the name entity recognition. It's going to be creating relationships as well. While that's doing that, I'm also going to upload a PDF. So this is a Parents' Rights in Special Education fact sheet, which again has more information about special education rights for parents in Vermont. So this is running and processing. So you're like, okay, that's again all well and good, but what do I do if I want to actually include this data here in my database, right? Like this is how I'm thinking about it already. Within the workspace, you can actually import like a CSV if you wanted. Of course, just to be clear, there is a Python driver. You can do all this with the Python driver, but what we wanted to show you is like quicker ways to get started. Why is this looks weird. Why is this not? Yeah, here. So let's say I could, let me delete this one. This is not the one that I want. This is not the droid I'm looking for. 1 second. So let's just say I want to upload a CSV file. I can go in, and this is my dear husband's Google Sheet. So what's going to happen is this actually shows me all of the columns that are in that CSV. So now, if I wanted to, I could create a new node that was, say, organization, and I'm going to map it from this file, which is organization, and I'm going to confirm that, and maybe I have a label document, and that document is mapped from file. Come on. The title, right, as an example. And we've got the organization has a relationship called produced, right? It produced this particular document. So now what I can do is I can actually run and import these, and I just click run import, and so it's going to pull in all of the organizations, all the documents, and add these. So let's see, we created, 523 rows. There were 72 nodes created, 72 properties. There were 431 documents. So 72 organizations, 431 documents, and 319 relationships. So now when I go back in to look at what I have, not only do I have the pieces that I added in, like the organization and things like that, but what we also have now is we have these two documents are also in here. Let's generate the graph. Generate the graph. It's generating that graph. So then what we can do is we can now preview the graph. So when we're previewing the graph, it's going to show us what it created. And so one of the things that we're going to see is we're going to see, because part of it was not only to create the graph, but to also show you what is the nature of what's in your documents. So here, obviously, it chunked everything for us. We've got those documents, and we're seeing, oh, there we have a number of social media pieces. We've got a number of web pages, right? We've got a number of different pieces. And this is showing you everything that was created in the graph from your unstructured data. So when we asked you, do you know what your data looks like, this is going to start to give you, come on, there we go. It's going to give you an insight into that, okay? So this is still running. We're previewing the graph. So what I'm going to do now is I'm going to go over, and what I want to show you is, let's do, actually, you know what? I'll do it this way. In Neo4j, this is Workspace, which is basically your Neo4j IDE. We showed you import, we showed you query if you want to write the Cypher query, but you can also just visually explore the data that's in there as well. So when we click on Explore, my internet is a little slow. Sorry, it's running from my mobile phone. I think this is where the Jeopardy theme song comes in. Do, 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 do. I know. Why don't they? Maybe can we change it so that whenever we build things and there's a waiting period, we can have a soundtrack? Anyway, regardless, so in the graph builder, we can see that this is now complete. Everything's uploaded. Everything's done. This used the web URL. Oh, yeah, these are all completed, right? Yes, the graph is generated. All right. Blah, 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 blah. Okay, so a couple of things. One of the things that we see now is that we can see that both of these unstructured pieces are loaded. We uploaded the CSV, and within the knowledge builder, you can now start talking to it. So you can just say, you know, tell me about who works in special education. I can't spell, sorry, in Vermont. Okay, and we'll ask this question. And it's going to go in, it's going to go into the graph, it's going to show us some things, and insert Jeopardy theme music here. The Vermont special includes several key players, and so then it goes through and it pulls them in. Now listen, we're used to seeing this in our RAG applications, but what we want to show you is that you can get to this graph place relatively quickly. And again, when we go through and actually look at the graph, some of the things that you're going to find is, so these are like some of our different documents, but you're gonna, let me turn off the chunks. Let me just look at entities. So you're going to start finding relationships between entities. So for example, what do we have here? These are probably Vermont Special Education. So these are each of the people that work there and their title, right? We can also see that this person is not only a member, but also holds, I don't know what this is, like probably holds a position with the federal and special education, something, I don't know. So what we start to find is we start to find, you know, different types of relationships among, you know, what we call sort of the multi-hops. What do we have here? What is this person? What do we have here? Okay. Oh, what is this? Oh, hold on. Let me see these here. What is this one? Oh, there's all kinds of interesting things to start looking at, right? So it starts to tell you a little bit about your data. Oh, right. So private school placement, different things related to private school placement, what it impacts. And so the initial thing that it's going to give you is it's going to give you a conceptual understanding of what's in your unstructured data. And it's going to take you straight to that graph. And as we showed, we not only have those organizations, but we can also say, like, what are some of the other organizations we had in here? I don't know, like, I don't know what other kinds of questions we could ask. There's a variety of things we can ask. So we get back to our idea of what's actually happening. So how do you do this? So one is in order to use the LLM Knowledge Builder, you can set up a graph database. We have a free tier, it's managed cloud, it's free, it'll always be free. So you can feel free to set up your own database. This is the link to the Knowledge Graph Builder if you're interested in giving it a go. The other thing to know is that if you have any questions, I'm really easily findable on LinkedIn, just Alison Cossette. Always happy to noodle with people and help them out. This is the link for Workspace, which will lead to, which is our IDE, where you can do the imports and all those pieces. And then the last piece is, and this is the GraphRAG blog. So for those of you who I said, again, who were really curious about the Microsoft piece and how you can use Microsoft GraphRAG, Microsoft GraphRAG leverages the concepts of graph data science, but it doesn't actually use a graph database. You can use Microsoft GraphRAG and then import those into Neo4j. And for anyone who is sad that you haven't seen any Python code, this particular blog is going to have lots and lots of Python code for you in it about how you can use LangChain and how you can use Neo4j to leverage those Parquet files from Microsoft, the GraphRAG product. Does anybody have any questions?
I think we have time for one more question, or one question.
Yes.
How is the latency of these graph generations, like with medium speed internet?
Yeah, the question is, what's the latency on the graph? So the graph query itself is actually pretty quick. Most of the time, and obviously this demo is not optimized. Most of the latency we find is actually in hitting the LLMs API. So in most of our applications, that's usually where we find it. But the graph query is very quick. Anybody has any questions, find me anytime. Thank you so much for your time. And hopefully we will see you all again sometime soon.
Thank you, Alison.